Question number 6. Question number 6 says the table below shows the value of Tom's car after T years. Alright? This table represents that, where the time represents the X, and then the value of the car would technically represent the Y. Okay? So the question continues to read. It says the function that best models the value of the car is what type of function? Alright? So we need to figure out which of these functions is represented by this table. Alright? So the first thing we're going to rule out is the absolute value function. Alright? Because an absolute value function means that you will have both positive and negative numbers. Alright? So again, it would mean that you have both positive and negative numbers. A value of a car cannot be negative. You can't be paying negative $40,000 for a car. So this one is automatically going to be out. Alright, that's the one that's completely off. Okay, because again, money cannot be negative. Money cannot be negative. Alright, so what we're going to now test if it's linear, exponential, or quadratic. Alright, so to test if it's linear, you're going to look at the difference between the numbers. Alright, so the difference between these is that you are adding one every single time. Alright, the difference between this is that we were losing. So here we lost 4,000. So I lost 4,000. All right. Here I lost 3,700. Actually, yeah. So 3,600. Sorry. All right. So to figure that out, guys, you can just do the difference of those numbers. So 36,000 minus 32,400. Yep, 3,600. All right. So that's the amount that we lost here. All right. Here we lost. So that one I don't know in my head. So I do 21,160. 21,060 minus the number that came in front of it. So this lost 11,240. Okay, so because we did not lose the same amount every single time, that means it is not linear. So again, it is not linear because we did not lose the same amount every single time. Now we're going to test if it's exponential. So to test if it's exponential, we're going to divide numbers. Alright, so we're going to divide the second number by the first number. So 360 or 36,000 divided by 40,000. Alright, and then we're going to divide the third number by the second number. So 32,400 divided by 36,000. Alright, if we get the same number, that means it is going to be exponential. So if I divide them, 36,000 divided by 40,000, we get 0.9. Okay, so this will give me 0.9. If I divided 32,400 divided by 36,000, which is the second number that came before it, I also got 0.9. Because I got the same number when I divided, that means it is exponential. Alright? So by default, it's not going to be quadratic. Alright? Quadratic would mean that the second differences are constant. So we would say the difference between these, alright? The difference between these numbers right here would be 400. Alright? However, the difference between these will not be 400. The difference between these numbers would be, so 11240 minus 36. The difference would be 7,640. Alright? Because that one is not constant, that's why we are confident that it is indeed exponential. Alright? Another way you could know that it's exponential is because it says after T years. Alright? After any amount of time is exponential. Alright, so again, that is also a way you can know that it's exponential. Alright, because it says after T years. Alright, so you know that that would be like y equal a parentheses r to the exponent t. Okay, and that's exponential. Alright, So it's exponential because why? All right. It says because it has a constant rate of change. That is not correct because when it changed every single time, this number was not constant. So it's not a constant rate of change. That is incorrect. All right. Is it because it's a constant percent rate of change? Well, a percent is a fraction or when you divide. So again, a percent is a fraction or when you divide. Right? So we saw that because it was exponential, how did we figure that out? By representing it as a fraction or by dividing it. Okay? So the answer would be that it's a constant percentage rate of change. So it was changing by 0.9 every single time, and we got that 0.9 by dividing the numbers. All right? This one would be incorrect because it says constant second difference, but we saw that the second difference, when we subtracted from these numbers, this had a difference of 400, this had a difference of 7,640. So again, it is not the second difference, but the percentage rate change. All right? So good luck, guys. Good luck.